Today we are looking at graphing systems of linear inequalities. Graphing a system is a lot like graphing regular linear inequalities. This time we're graphing more than one inequality on a graph. Here we have the problem x plus 2y is less than or equal to 6 and x minus 3y is greater than or equal to 4. What we're going to do first is take a look at our first inequality. X plus 2y is less than or equal to 6. We need to figure out our 2 points, 0, comma something, and blank, comma 0. In order to do this, we pretend that x is 0. If x is 0, we get left with 2y is less than or equal to 6. So y is less than or equal to 3. Since we're looking for the boundary line, we're pretending it's an equal sign. So we say we have the point 0, 3. We do the same with x. X is less than or equal to 6. Pretending again it's the boundary line, we have the point 6, 0. Next we'll look at the second inequality. X minus 3y is greater than or equal to 4. Starting off we can plug in 0 for x, and then we will plug in 0 for y. If I plug 0 in for x, I get left with negative 3y is greater than or equal to 4. Y, in this case, because we would flip the sign, y is less than or equal to negative 4/3. Looking at the boundary line, so we're pretending it's an equal sign, we get negative 4 over 3. Now, if we plug 0 in for y, we get x is greater than or equal to 4. Again, looking at the boundary line, so we pretend that it is an equal sign in between the x and the 4, we get x equals 4 when y is 0. Next up, we're going to try and graph these lines. I'm going to focus on one line at a time. Otherwise, I might confuse myself. And confusion is something we don't want to have in mathematics. So, forming my graph, making sure I go out far enough, I'm going to first plot my blue line, figure out where to shade it, and then focus on the red one. So looking at my blue line, I have the point x is 0, y is 3, x is 6, y is 0. We have the equals to, so we do have a straight line, and it is solid. Now we've got to look at where to shade. To figure out where to shade in an inequality, we need to pick a point that is not on our boundary line. Here I'm going to use 0, 0 since 0, 0 is not on my boundary line. If x is 0 and y is 0, I get 0 plus 0 is less than or equal to 6. Last time I checked, 0 is less than or equal to 6, so I can then shade everything the same side as 0, 0, which would be everything down here. We are halfway done with our problem at this point. Now I need to graph my red line. When x is 0, y is negative 4/3, so that is negative 1 and 1/3, about there. And x is 4 when y is 0. Again, equals 2, so it's a solid straight line. In this case, I'm not worried about the intersection point. I mean, I know there has to be an intersection point, but I don't really need to know what that value is. Now we've got to look at shading our red line. So again, pick a point that's not on our boundary line. 0, 0 works in this case as well. So we plug 0, 0 in for our red line. 0 minus 3 times 0, which is 0, is greater than or equal to 4. So I'm looking at 0 is greater than or equal to 4, which if you check in a calculator, 0 is not greater than or equal to 4. So we shade everything away from 0, 0, which ends up being everything in this direction. Our answer is where both areas are shaded. So our final solution ends up in this area down here. We're looking for where there's overlap between the two lines. The next problem I have is x plus y is greater than 0 and y plus 2 is greater than 0. In this instance, trying to plug in 0 for x and 0 for y won't get me anywhere in my inequalities. If I tried it for the first one, I'd get 0, 0 both times. So I know that the first line has to cross through my origin. If I tried it with the second one, I'd have 0 plus 2 is greater than 0, which doesn't work. So I'm going to have to rewrite these inequalities in y equals mx plus b or slope-intercept form. Starting off with my first inequality. If I subtract x from both sides, I get y is greater than negative x. And if I rewrite my second inequality, y is greater than negative 2. If y is greater than negative x, I can start by graphing that. By plugging in points. If x is 0, y is 0, as we've established before. If x is 1, y would be negative 1. X is 2, y would be negative 2. So let's plot those points. X is 0, y is 0. X is 1, y is negative 1. X is 2, y is negative 2. If we go the other way as well, if x is negative 1, y is 1. So our line will go diagonally in this direction. Of course, it has a negative slope since we have a negative x. In this case, since we don't have the equals to, we will end up with a dotted line. Up there and down here. Now I'll look at graphing my red line. No matter what my y value is, no matter what my x value is, my y value is always going to be negative 2. So I start off at negative 2 on the y-axis. Then I have 1, negative 2, 2, negative 2, 3, negative 2, negative 1, negative 2, negative 2, negative 2, so on and so forth. So I end up with a horizontal line that once again is a dashed line. Now I didn't go in and shade this time, so I need to go back and shade. Let's first look at our blue line. We pick a point that's not on our line. This time 0, 0 doesn't work because 0, 0 is on my boundary line. So let's try plugging in another easy point, for example 1, 1. If I plugged in 1, 1, I would get the inequality 1 is greater than negative 1. This is true. 1 is bigger than negative 1, so I shade everything the same side as 1, 1. Everything up above the line in this case. Now we look at the red line. Pick a point not on my line, say 0. So 0, 0, in this case y is 0. 0 is greater than -2. This is also true. So this time I'm going to be shading everything above my red line. And again, we're looking at where the colors overlap. So we're going to end up in this area here. You're not wrong to shade after you've drawn both lines. Some people find it easier to shade as you're going along. Some people find it easier to shade once you've done both the graphs. Either way's fine. Both are very valid ways to do it as long as you get to the same answer. I don't care how you do it. The final example we have is 3x plus 2y is less than or equal to 6, and 2x plus 3y is greater than or equal to 6. So for here, we're going to first figure out what our points are for our inequalities. So 3x plus 2y is less than or equal to 6. If x is 0, we get left with 2y is less than or equal to 6. Divide both sides by 2, y is 3. If y is 0, we get 3x is less than or equal to 6, so x is 2. For the second inequality, 2x plus 3y is greater than or equal to 6. Plug in 0 for x, y is 2. Plug in 0 for y, x is 3. We're then going to proceed to graph our inequalities, starting with the blue one first. So we have x is 0, y is 3, and x is 2, y is 0. Less than or equals to means we have a solid line. And if we try and shade this, plug in a point that's not on the line, 0, 0. 0 plus 0 is less than or equal to 6, which it is, so we shade everything the same side as 0, 0. Now we'll graph our second line. 2x plus 3y is greater than or equal to 6, so 0, comma 2, x is 0, y is 2, x is 3, y is 0. Again, we have the solid line. Again, we could try and plug in 0, 0. 0 plus 0 is greater than or equal to 6. This time that is false, so we shade away from 0, 0. So it means that we shade up here. And this time we only get left with a very small region. Everything that is in this little triangular region here, between the red and the blue lines.